Okay, so those of y'all that are virtual, check the chat box. I updated the homework, but just to summarize, if you're AP, your homework is for the first two assignments will both be due Monday. Dual credit, that assignment that was released yesterday will also be due Monday. So I'm about to take attendance and then we'll get started where we left off yesterday. Here are we missing? I'm not missing anybody here. Everybody's present.
We really got a small class.
Y'all do. Yeah. So based on what we did yesterday, what are y'all's thoughts about statistics so far?
All right.
Kind of confusing?
I like the content. It's just like got to look and do the like the homework a little bit. Not bad.
Gotcha. Yeah, that's one thing with stats. There's, especially the deeper we get into it, it's like just more and more starts going on. It's like, good grief. But it all kind of starts, it's like at first I feel like it spreads out. And then towards the end, you just start tying everything together. So, okay, I've done attendance. I won't get a call from the office. Let's pick up where we left off. Today, I will say today there's going to be a few activities, so you'll get to talk with your neighbors. It's not just, hear me lecture, write this down. We're going to do a few activities. Make it a little bit more interactive. So, come on, click. So yesterday we left off talking about the two different types of statistics. One of them's up there. We have inferential statistics. What was the other one? Descriptive. That's right. Which one would we use to do analysis? Inferential or descriptive? Like if we wanted to do our formal analysis and make a report of it.
Description.
It'd actually be the inferential. The inferential is the one where you really get your hands dirty, you really analyze it, and go from there. Descriptive, that's just organizing and summarizing and just trying to really get just a brief, okay, this is where my data is headed. Inferential is like, this is where it's headed. I want answers to these questions. Let's go. So we left off. I didn't realize there was one more slide to this section after we did that part. But just a little discussion on important terms. Remember, and we mentioned this yesterday, it's usually not reasonable, feasible, or even possible to survey a whole population, so that the descriptions and decisions can be made about the population. I mean, what were some reasons we said we couldn't sample the whole population? Or not sample, couldn't get data on the whole population? Money, time, inaccurate data reporting. Those are all reasons. So we use samples. So the study of statistics deals with understanding how to obtain the samples and work with the sample data to make statistically justified decisions. So let's look at section 1.4. We'll start talking about a couple of different types of data and then some simple graphical displays. One of these, they call them a bar chart. You'll look at that and you're like, okay, yeah, this is simple. I did this in elementary school. It's just a bar graph, but they give it, for some reason, they call it a bar chart. But I guess it is a chart. Anyways. So, first thing, a variable is any characteristic whose value may change from one individual to another. If I ask the question, does pineapple belong on pizza? And then I went around this room and asked each and every one of y'all, would everyone have the same answer? No. Some people would say, yes, it does. Some people would say, no, it doesn't. Personally, I think it does, but anyways. Suppose we wanted to know, so going back to our GPA example, suppose we wanted to know the average GPA of high school graduates in the nation this year. What would be our variable of interest? What are we trying to find? GPA. We're trying to find GPA. So the variable of interest is the GPA of the high school graduates. So the key here is don't try to overcomplicate it. If you want to know something, that's your variable. It's what you want to know. Now, I'm going to just put this up there, but take it away because I think some may still have been trying to get it. If we looked at the number of wrecks outside the school at this intersection, let's say that's what we were studying, could the number of wrecks be considered our variable? Yeah. If that's what we're studying, sure. It could be considered the variable. Now, if we were wanting to know the color of the cars, would we care about the wrecks? No. But if that's what we were studying, that'd be our variable. Yes, that would be. So now let's talk about data. I don't know why. Sometimes I say it data, sometimes I say it data. I don't know the right way to say it. But data, they're the values for a variable from individual observations. If you start listening to a bunch of statisticians talking about their research, they'll just start, instead of saying this observation, that observation, I guess it just rolls off your tongue easier to say data point. this data point, that data point. And so, really, in the future, if you start hearing me say data point, just know it's observation. I'm talking about observation. So for the variable, the number of recs per week at the intersection outside the school, what could our observations be? If we're looking at the number of recs. So if I'm sitting out there today on Wednesday, and I have to report back how many recs, what are some things I could report back? The number, yeah. Yep, that's right, the number of recs. 0, 1, 2, 3, so on. Would I report that there's a red rec and a blue rec and a black rec? Would that make any sense?
Nope.
No. So what y'all just told me is there's different types of variables. If I can't just report anything, that means there must be different types. And there are. There's two types. We have categorical. So that's where you group things into categories, just like it sounds. And then you have numerical. So an example of categorical would be males or females. You drive a blue car, red car, yellow car. That's categorical. What do y'all? Well, let me back up. Hang on. I'll ask that question here in a second. Then we have numerical. So there's categorical and numerical. But then numerical splits off into two more branches. You have discrete. So what discrete means, and I'm getting ahead of myself, but anyways, discrete is isolated points. They can't, it's got to be just certain numbers. You can't have a whole range. Continuous is where it can be anything within a reasonable range. So let's first look at categorical variables. They are qualitative. And that means they identify basic differentiating characteristics of the population. So male, female, economic status, that's a categorical variable. Yes. I didn't see any. No. So can y'all think of any categorical variables? I mean, I know I've been naming them all period. But what are some categorical variables? Gender. Color. Physical traits. Yep. Those are all categorical variables. Numerical variables, they're quantitative, meaning that they're observations or measurements that take on numerical values. So on these, it makes sense to average the values. But there's, as we learned, there's two types. Let's see. Okay. Second type of numerical variable. Okay, so Yusuf, the second type of numerical variable is the continuous. So you have discrete and continuous, just like it also says at the bottom of the slide there. Or I can also go back. Give me 1 second. Hang on, I just need, let's go back. Our virtual one just saying I'm going too fast. So we got numerical, two types, discrete and continuous. Let me ask you this. Grade level. What kind of variable do y'all think it would be? Categorical or numerical?
You said grade level?
Mm-hmm.
That'd be categorical.
Categorical? But why? It's 9, 10, 11, and 12.
But it's like saying which one are you, there's like different people.
That's right. That's right. So grade level would be categorical. And another way to think of that is it would make sense to say, oh, the average grade level at Lufkin High School is 10.5. How can you be in 10.5 grade? I mean, I guess you could say, oh, well, that's in that 10th graders in December. But, yeah, it doesn't work like that. So we've got our categorical, numericals, discrete, and continuous. So now let's look at each of those individually. Discrete numerical variables. They're isolated points along a number line. And they're usually counts of items. So going back to our wreck in front of the high school example, you wouldn't come back and report to me, there were 3.5 wrecks outside. You're either in a wreck or you're not. It's either a wreck or it's not. So those are discrete. That's an example of a discrete variable. So 0, 1, 2, so on. That's discrete. Continuous, they're a variable that can be any value in a given interval. And those are usually measurements of something. So heights, age. I mean, usually you don't walk around and say, I'm 16 and a half years old. Or I'm 16 years old, 3 months, 2 days, 5 hours, and 28 minutes old. I mean, you could, if you keep track of it, you could do that. I wouldn't say you're crazy. You just really want everybody to know exactly how old you are. Okay, so now we're going to have a little activity here. I'm going to just group y'all by rows, basically. So there's 5 on the next page. There's 5 different variables. I want y'all to classify each of them as categorical or numerical. And if they're numerical, you have to say what kind, continuous or discrete. So here's how I'm going to do it. Y'all can be one little group. Y'all are going to be number 1. That 4 row, number 2, number 3, 4, and then 5. So I want y'all to look at your given number, and you can talk amongst yourselves and try to figure out what kind of variable your given number is. I'll give y'all about a minute or so. Third period got into a debate on a couple of them. So I'll give y'all about a minute or so to talk amongst yourselves.
Yeah.
We're only doing one.
Y'all are doing number 5. Number 5.
Yeah.
I kind of think it. Okay, so isolated more, that would be.
It is in America.
Oh, we're. Oh, yeah.
Isolated points.
You can't.
Mr. Schultz, what is a phrase, man?
You can't do like.
So, like, what the county says your home is worth.
Okay, so it's like a specific value. So, yeah, actually, I think it's specific. Because like I say, like, everything is specific.
Like, what do you? Yeah,
because it's like a phrase value, so it's not more.
Yeah.
Okay. So I guess we'll start. Number 1. Who was group? Y'all were group 1, right? What did y'all think for? What did y'all think for the color of cars? It is categorical, yes. Okay, group 2. What did y'all think for the number of calculators owned by students at your school?
Numerical.
That was right, yes. Yep, that's right. No joke, I think last period I was telling them about how many calculators I had to get in college. I think now I'm up to like I own 8 calculators, not including my phone or computer. So I get to college and I have a TI-89 because that's what we used in calculus. And my first professor was like, "That's too powerful. You can't have that one. Biggest you can have is a TI-83." So okay, fine. So I went got a TI-83. I get to, I think it's the next semester. Will the TI-83 work? No, can't have a TI-83. You have to only have a scientific calculator. Okay, fine. So then I went out and bought this one, TI-36. Had that one for that semester. I get to the next semester, and I have to take like this big test at the end of that semester, and they say, the only one you can use on that test is a TI-30. I have to go out and buy a TI-30, which is pretty much just like this one. It only does maybe one or two things less. But whatever. And then the next year, you need a TI-BA2 Plus, which is like a financial business calculator. And I had to have that one to take a test. So I went and bought that one. I'm thinking, good grief, how many calculators can one person have? I'm going to be like that person that's got chapstick everywhere. Have one in my car, have one in my bedroom, have one in my kitchen. I mean, my gosh. Because I get to the next class and they're like, you can't have anything other than a 4-function calculator, and it can't be on your phone. Oh, looks like I'm going to buy a 4-function calculator. Then I'll start working here, and they're like, oh, by the way, we use the TI Inspires. I'm like, the what? They said, the Inspires. Okay, I guess I can go buy one of those and play with it, because I have no clue what that calculator does. So I went and bought the Inspire. So let's see, 83, 89, 30, 36, BA2 Plus, 4-function, Inspire. So 7 calculators. Now, do they all work? That's a different story. I think one of them, the battery's been dead for like 3 years now. But anyways, group 3, zip codes.
We said continuous.
Continuous? What do y'all think continuous? Categorical? Why do you think categorical? So it is categorical, and the reason is you can't, it groups. If I went through and asked everyone here what your zip code was, chances are it may be the same. But if you go to NAC and start asking people in NAC, they give you their zip code, and you're like, oh, you live in this area. So your zip code kind of categorizes you as to where you live. You can't have continuous. There's only so many zip codes. So zip codes are categorical because they categorize you based on where you live. Group 4, the amount of time it takes you to drive to school.
We said numerical.
Okay, why did y'all pick that one?
Because time is like a measurement.
Mm-hmm.
So this is
Yep. It's numerical continuous. And then the last one. Numerical. Okay, which one? Discrete. Why'd y'all pick numerical discrete?
It's like a 50 value in a
Yeah. So they give you a hint here. Is money a measurement or a count? It's a count. So it'll be discrete. And last period, kind of the example I gave is you wouldn't go, the county wouldn't come to you and say your house is valued at, let's say 100,000, whatever, 0.3567896. The they just round to the nearest cent. Really, they'd round to the nearest dollar. Most counties just round to the nearest dollar. But yeah, it's discrete, definitely. Okay, questions on naming the different types of variables. Okay. So now they want us to classify variables by the number of variables in the data set. So let's suppose a PE coach records the heights of each student in his class. This would be an example of univariate data because it is a single characteristic of the population. He's not writing anything else about them down, only their height. Single characteristic.
So like in that case, you wouldn't even like write a name, it would be like the
You
height
don't even have to write a name. You can just, how tall are you? Okay. How tall are you? Okay. Wouldn't have to write even a name. And we'll see an example of that in class at the end. Okay, now let's suppose he records the height and the weight of each student. How many variables did he record this time? 2. So this one would be an example of a bivariate data set. There's 2 variables. And then let's say they get a little, since they are in PE, let's say they do a little bit of physical activity. Now he does height, weight, number of sit-ups, and number of push-ups for each student. This is called multivariate. So after we get past 2, we're just like, okay, he's looking at multiple variables. We're not going to sit there and try to say, that's trivariate, quadvariate, all that. No, it's just multivariate. However, multivariate data is beyond the scope of this class. So it's more than 2 characteristics, but that's beyond the scope of this class. I didn't get into that, I think, until the second semester of my sophomore year or the first semester of my junior year of college. So, why am I going to get that for? Because then you have to start looking at, okay, so I've got all these variables. Well, how do they play into each other? Like if he's going to try to predict your weight based on your height, sit-ups, and push-ups, well, these 2 may be tied together. So then that's going to impact the data, and yeah, that just gets way too complex. So now let's talk about frequency distributions. So a frequency distribution for categorical data is a table that displays the possible categories along with their associated frequencies or relative frequencies. A frequency is the number of times the category appears in the data set. So if we were going through and we were just writing down the color of the cars in the teacher parking lot, just seriously give that away. Or did we already talk about that? No, that was that other example. So I'm just sitting there writing down color of the cars. The frequency would be how many red cars, how many blue cars, how many white cars, how many neon orange cars. Relative frequency is the fraction or proportion of the time the category appears in the data set. So relative frequency would be like saying 25% of the cars are white. That's relative frequency. You calculate that as, did we have a question?
No, I was just saying, how do you
It's calculated as relative frequency equals frequency over the total number of observations. So when the table includes relative frequencies, then sometimes we call that table a relative frequency distribution. So if you're one that you like to maybe underline or highlight things just to make them stand out, just remember relative frequency is a proportion. Relative frequency, proportion. Those two go together. Normal frequency is just a count. Okay, so let's look at an example that they have in your book. If you want to read more about the study, you can look on page 12 of your book. But they did a study on motorcycle helmets, and they called it, "Can You See Those Ears?" So, honestly, I haven't read much into the study, but I'm guessing that if you're on a motorcycle, you probably don't want to be able to see their ears. So what they did is they went and they counted those that had no helmet, those that had non-compliant helmets. Those are the ones that you can see the ears on. I mean, just thinking practically, if you're driving down the road and you get in a wreck going 60 miles an hour, if you're pretty much your whole head's not covered, there's going to be serious damage. But if your whole head's covered, then your whole head theoretically would be protected. And then compliant helmets. Now, the way they got the relative frequencies is first they had to get the total number of observations. Just remember, our formula for relative frequency said it's the frequency divided by the total number of observations. So first they had to get the total. And then they just divided the actual frequency. Where is it? There it is. So 731 divided by 1700. That's what gave you 0.43. That arrow is kind of off a little bit. It should be pointing up there. And then they went to the next one. 153 divided by 1700. That's what gave you 0.09. Oh. Then they went to the next one, and they just kept working all the way down. Now, once you found the relative frequencies, one real quick, easy way to check is they should all add up to 1. If you add up all relative frequencies, they should add up to 1. Now this may be slightly off due to rounding error. So it could be, you may see it 0.999 or 1.001. It could be off due to rounding error. That's one way to check. Okay, let's talk about bar charts. So when do we use bar charts? We use them when we have categorical data. Now, how do we construct them? Well, first, we draw a horizontal line. We'll write the categories and labels, or labels, below the line at regularly spaced intervals. Basically, you put your x-axis in there. Then you draw a vertical line and label the scale using frequency, or you can use relative frequency. And then the third step, you place equal width rectangular bars above each category label with the height determined by its frequency or relative frequency. So they say bar chart, all this really is a bar graph. So what do we look for? We look for frequently or infrequently occurring categories. So if you see one that's really high and then another like next to nothing, that may be something to take note of. Okay, so now we have an activity. We want to collect data and then display the data in a bar chart. So our question, and this is to everybody, including the virtual learners, what is your favorite ice cream flavor? So I'm going to set up our area here. Do it on here, that way they can see it too. Okay, so let's see. Let's start setting a chart up here. What are our options for flavor? Vanilla, chocolate, strawberry, or other. Okay. So those of y'all that are virtual, if you will put your favorite flavor in chat, please. That way we can include y'all's numbers too. Okay, well, let's go through and get a frequency going. So, I need to be over here so I can monitor chat. So pick your flavor, or pick, maybe you don't like ice cream, just pick one. Humor the rest of us. Okay. How many like vanilla as their favorite flavor? Anyone like vanilla? Nobody?
Wait, we talking bluebell or like just regular ice cream?
Whatever your favorite brand is, the flavor you would go get.
I'm just going with regular ice cream.
Okay, no one wants vanilla? Well, someone in chat said vanilla. Just, well, let's see. So, vanilla's got one. One vote. Someone in chat said vanilla. Chocolate. How many like chocolate? Let's see. 1, 2, 3. And 2 on chat, so 4, 5. 5 said chocolate. What about strawberry? 1, 2, 3.
I thought we were gonna be the only one.
4. There's 4, so 4 said strawberry.
I usually do chocolate.
Other. Everybody else better raise their hand. 1, 2, 3, 4, 5, 6, 10. Yeah, I think they left cookies and cream out here, but
Oh, no.
okay. So now let's calculate their relative frequencies. That needs to be a key. Relative frequency. What do I need first before I can start calculating this column? I need total. Well, I kept it easy. I thought about voting, but let's keep it easy. 20 is an easy number to work with. Okay, so relative frequency. I divide the frequency divided by the total. So 1 divided by 20. We need these all as a decimal.
What's that, 105?
0.05. 5 divided by 20. 0.25. 4 divided by 20. 0.2. 10 divided by 20. 1/2. And then, just to double check that all of our math is right, it's always a good idea to add them up. So you add them all up and you get 1. Okay. So now let's do a bar chart based on this data.
They have to be big or no?
This will have to be big.
Like the chart?
Just wherever you can fit it in there.
Alright.
Wherever you can fit it in there. Okay, so I'm gonna don't you wish you could like actually do this with the pencil, just draw a perfectly straight line without a ruler or anything? Okay, let's see. We have vanilla or vanilla. Chocolate. Strawberry. And then other. What should we count by? 5s?
Do ones.
We could do 1s. I'm gonna do 2s just to space them out. So, 2, 4, 6, 8, 10. And since we're doing counts here, how would I label my y-axis? Frequency or relative frequency? This would be just frequency. X-axis would be flavor. Okay, now we draw our bars in there. So vanilla had what, 1? How many did chocolate have? 5. Strawberry.
4.
And then other. Ideally, those would be evenly spaced out, but yeah, that didn't happen. And they would be an even size. What do we notice about just looking at this chart? What are some observations we can make? Was it vanilla what?
Vanilla's not good.
Yeah. Nobody likes vanilla.
And the majority of people like other stuff.
No one likes. No one likes vanilla.
I'll do it. We'll get it done. That's a good catch.
I was gonna say no one really likes vanilla. I mean, someone does. One person does. But
Yeah.
most people like other flavors.
Actually, half.
Yeah, that's true. That's half. It's not most, it's half. Half like other flavors. Mhm. So those are two good observations that we can make just looking at that. And then just a little, you don't have to write this down. This is just a little insight. If you're analyzing data, what some people will do is they'll sit there and figure out, okay, what's an okay number to have in other? Without having a million categories, I mean, is half of your people being grouped into other acceptable to you? Maybe, maybe not. Personally, I think that's kind of high. But, I mean, we didn't have another option. So.
If you probably like added one more category, it'd probably been a lot more spaced out.
Yeah, especially if we had cookies and cream. Somebody may have said, well, it's not my absolute favorite, but I'll stand for it rather than being thrown into other. Okay, so that's a bar chart. The other kind of chart we're going to look at are box plots. Not box plots, dot plots. We will get to those, I promise. We'll get to box plots. Everyone's included. Even if it's thrown into other, everyone's included. Okay, I want PowerPoint. So now dot plots. They're actually even easier to draw. And you use them with small numerical data sets. And the reason you want small data sets is, I don't know about you, but I don't want to sit there and put 1,000 dots on a piece of paper. And last period we saw real quick why you also want it small. So how do you construct them? You draw a horizontal line and mark it with an appropriate numerical scale. And then you locate each value in the data set along the scale and represent it by a dot. If there are 2 or more observations within the same value, you'll stack the dots vertically.
Oh, I think I've seen one of these before.
You'll probably have. Oh, some are still, may have still been writing. Okay, everyone done writing? Okay, so what to look for when you look at a dot plot? Why I keep saying box plot, I don't know. Bless you. The representative or typical value, so what value really stands out among everything else. The extent at which the data values are spread out. The nature of the distribution along the number line. So are they grouped together? Do you have 2 or 3 little groups? How do they look? And the presence of unusual values. So it's like all the data grouped in one area and then way out at the other end as a single point. So those are things we want to look for on that. So we want to collect the following data and then display it in a dot plot. The question is, how many body piercings do you have? So if you're virtual, put that answer to chat, in chat. That way we can include y'all again in the data. Here in person, we're just going to go around the room and we're not putting names, we're just writing numbers. So, okay. So I guess we'll start with you, Riley. The answer to the question, how many body piercings do you have?
I got 3.
3.
I got 0.
0? Tiger? 2? Okay. 2? Okay. 2? None? 0? Okay. Brandon?
Oh, 0.
2? 3? 2? 2? Okay, over here on this side. I don't care who wants to start over here. 2? Okay, Will?
0.
0? Okay. 0? 0? Okay, let's see what chat says. Someone last period said 8. Okay, 0, 0, 0, and 4. Okay, so 0, 0, 0, and 4. So now we get to make a dot plot with these values. Oh, I didn't include mine. We'll add an extra dot for me. 0.
I thought you were going to put numbers.
No.
Short got 5.
So, funny story. Y'all know how when you're growing up, especially when you're little, you tend to repeat stuff you hear adults say and whatnot. So my grandfather, he always says, like, if you have earrings, you must have ruffles on your underwear. We were walking through Walmart. I wasn't there, but my brother was like 2 or 3. And this guy walks by with earrings. And in the 2 or 3-year-old voice, Mommy, does he have ruffles on his underwear? And she's like, Randy, where did you hear that from? That's what Papa says. We don't say that. But yeah.
You gotta hear it.
I don't know if he heard it or not.
I was fine.
Yeah, he probably walked off like, okay. But just, yeah.
I'd be laughing at somebody.
I'm just doing this. Okay. So let's start putting points on here. We got 0. Then we have 3 2s in a row. Three zeros in a row. Two, 3, 2, 2, 2. How many zeros? That's 6 zeros. 1. I'm not going to have enough room. 3, 4, 6. A 4. And then I'm going to take my observation off because I'm out of room. There's our dot plot for number of piercings. So what are some observations we can make based on this? Yes.
The vast majority don't have piercings.
The majority don't have piercings? Yeah, I think we're about half.
The majority of it have 0 or 2.
Yeah, let's say that. I would say the majority. If we wanted to say the vast majority, we could. The vast majority have 0 or 2 piercings. Do the observations tend to be spread out or close together?
They were close together.
Yeah, they're pretty close together. So observations close together. That's about the extent that we could say. We don't have one that's an outlier really, because I mean you got a 3 and then a 4. You don't have one like we had in third period out there at 8.
What?
So no real outliers. Yep, that's that. Any questions on 1.4 or anything we've done today or yesterday? Y'all have 20 minutes. You can work. I'll probably work on the assignment.
Can I take a nap?
I mean, you can. It's
I've
your
already
time.
worked on these something.
Okay. Yes.
All right.